Good evening, everyone. It's another beautiful Tuesday again. Today, with great joy in my heart, we have a new masterminder who is going to share with us some of his experience as well, and who will bring a lot of knowledge to us this evening. And we're going to be talking on ship compass. So with that, I would like to welcome my new boss, Captain Olubunmi Johnson. So the floor is yours now.
Thank you very much, sir. Thank you very much, my captains in the house. It's my pleasure to be here. Really appreciate you guys. When Captain Tayo told me about this, I said, this one, I'm not good at teaching. No. They said, don't worry, you are born ready. I said, okay, no props. I'll try my best possible to share out of the little knowledge I have. Of course, little story about me. I went to a foundation school of oceanography, Federal College of Fisheries and Marine Technology, and after I proceed to UK for my OW. Before that, I went to Oran for my OW, and later I went to UK to start afresh. So I went to South Sheets, that is Southern Side College in the UK. For my chiefs, I went to Liverpool John Moss University. While for my class one, I did that online class with Glasgow Maritime Academy. Yes, it has been quite challenging because, of course, to raise the fund, it is not easy like that, but with God, we tried our best possible to get there, unlike, not being sponsored. So it's quite a bit challenging. But of course, with determination and with focus and saying, okay, this is what I want, I think in life we can achieve anything, Maybe time may pass, but God is there for us. That is what I believe. Yeah, today I'll be sharing with us about magnetic compass, basic magnetic compass. Yeah, because compass is a very broad course. So of course we cannot talk much about it, but we can talk about the basic ones. For example, I can see in the group people preparing for their OW class 1. I mean class 3, sorry. So I'll be starting with the advantage of magnetic compass. Of course, every one of us, we sight a magnetic compass on our ships, on our various vessels, and of course we use it as a cadet. We just will, and we really don't know the real function or the care or the composition of a magnetic compass. But as soon as we are being promoted to the other level, like being third officer, second officer, we start to know what we need to do, the care of a magnetic compass. So why do we need a magnetic compass on board when we have a gyro, which is quite, more accurate, than magnetic compass? Basically, we need magnetic compass because it doesn't use power. There's no source of power for magnetic compass. Only magnetic compass is when your auxiliaries are down, everything are down. You see your magnetic compass still functioning. and still taking you to your destinations. So, of course, we used to have this portable magnetic compass that we take around. You can know that, okay, you don't need to get a battery for this or get any generator or any light source of power to this before it functions properly. Then we see this compass trying to seek north all the time. Then we say, okay, what is happening here? How does the compass seek north? The reason why the compass seeks north is because it has some magnetic needles under the compass card. Please, I will, after everything, I will ask some questions, and I will want this to be an interactive class section. So underneath the magnetic compass, we have the needles, some needle inside under the magnetic card, which points through magnetic north. So north through north is magnetic north. I'll try to share something so that we can know the difference between true north and magnetic north.
You want to share the screen?
Yes.
Okay.
Okay, I hope we can cite this.
Yes,
yeah,
we can see.
Okay. This, as we can see, this is the geographical pole, and this is magnetic pole. There's difference between geographical pole and magnetic pole. We all know that, okay, the Earth rotates about its axis, and we have the magnetic field that covers the Earth. So, but this magnetic field has its own pole, its own north, not like the geographical north. So there's a difference. That is what the compass, magnetic compass, actually seeks. It seeks magnetic north, not geographical north. So the difference between this is about 11.5 degrees around it. So at this point, we can emphasize, okay, what is, with what I've read, I think it's about 86.3 degrees to the north. So to the geographical North Pole. And the angular difference between this is called declination. Declination is different between the magnetic north and the true north. Of course, on our ship, we steer our magnetic compass. But on our chart, if you say you want to be steering our magnetic compass, where will it take us? Take us to another destination. So, of course, we want to steer through compass. How do we steer through compass? Is by converting our magnetic compass heading to true heading. So, of course, we have to calculate the difference between this, and which give us the declination. Declination is where we get our variation from. Then I need to share another screen. So can we all see this, please? Can we see the screen? Oh, okay. Yeah, this is the compass rose. We have this on our navigational chart. This is where we get our variation from. So which is the difference between the our magnetic core north, course heading, and our true heading. Okay, so we do proper calculation for this, which you can also do. These oral preps. So after getting our variation from here, we can see 2005. From 2005, we can convert this to 2021 that we have. Depends on the location we are on the chart. That will tell us, okay, are we going to add or subtract? Is east or west of the pole? So this will give us our calculation for variation. Then we convert our magnetic north to true, our magnetic heading to true heading. So with this, yes, with this we know our true heading. And what is the composition of magnetic compass? Of course, from our wheelhouse, we cited, we know that there's this big thing at the Monkey Island, and of course, we as maybe as cadets, we don't know. Okay, what is this? What are the composition? What do we have there? So we have hold on, sorry, hold on a bit. Okay, can we cite this, please? Okay, so this is composition of what we have at our Monkey Island. This is a magnetic compass. We have the binnacle, we have the quadrilateral spheres, we can call it a Kelvin's ball. We have the Flinders bar. We have the hard iron magnets. Anything you see outside this magnetic compass are called soft iron correctors. For example, this Flinders bar is used to correct forward and aft soft iron magnetism. Why this Kelvin's ball are used to correct forward and aft, including at worship soft iron magnetism. Then in here we have healing error magnets, about 1 to 8 magnets, depending on the correction done by the compass adjuster. We have it in here. This is the housing for the healing error bucket, which contains the healing error magnet correctors. Then in here we have the forward and aft magnetic ions. This is the tray in here, but inside it we have forward and aft magnetic ions. These are correctors. They are used to correct forward and aft magnetism. Yeah. Then we also have in here, we have at worship magnetic tray. This consists of the hard ions magnetism, which is forward and at worship hard ion magnetism. So these are hard ions magnetism, while these are used for soft ion magnetism. So of course, I wouldn't want to go in deep in that, because that is quite advanced. That's for people preparing for maybe class 1. Yeah. So in here we have our compass ball with our compass card in here. So how does it what do we have in the compass ball? We have our compass card, which it can be wet or dry card. Wet card are made of mica and plastic, while the dry card are made of rice paper. So that is what we have in the compass ball. Also, we have a liquid inside it. That liquid contains the two part, which is distilled water and ethanol. The distilled water and ethanol, which has a ratio of 2:1. The distilled water is 1, while the ethanol is 2. So when measuring the quantity of this inside your compass ball, that is the ratio in it. Then why do we have ethanol in it? Sorry, ethyl alcohol, not ethanol, sorry. Ethyl alcohol in it. Why do we have ethyl alcohol in it? It's because we don't want the water to freeze when we go to cold regions. Example, the polar regions, the Arctic, maybe Atlantic, near where we have freezing, where we have ice. You understand what I mean? So we do not want our the liquid inside the compass ball to freeze. So this effect helps until about minus 35 degrees. So you are assured that your compass, the liquid in your compass will not freeze to about minus 35 degrees. So, and when you find, okay, for example, now you find your liquid in it is frozen. What do? You, of course, you know that, okay, the ratio, the combination between the distilled water and the ethyl alcohol is not proper. So what do? You try and remove the ice in it and change it to a new one. You know, of course, you may have delay. What do you do first? You go into your room, compass room, then you've taken every ship should have a spare compass ball, which is being stored upside down. Why this is being stored upside down is because you want this compass, you know, the function, it's always seeking north. So that means your compass is always working. You know, to maintain it, to give it fresh, to keep it fresh, you want to store this compass ball upside down. So of course you change it. But if you don't say, okay, let's manage it, or you can't do that. What you do is just to discard the liquid inside it, then to put fresh liquid in it with a percentage of ethyl alcohol 2, and the ratio of ethyl alcohol 2, and distilled water 1. So another thing that we can find in the compass ball is bubbles. When you check, during your check, maybe weekly check, you find bubble in the compass ball. What do? You make sure that you remove the bubble. How do you remove the bubble? There's an opening in there that you will introduce a fresh ethyl alcohol. You don't introduce distilled water. Don't do that mistake. Let's try not to forget this. You introduce ethyl alcohol into this, and that will remove the bubble in it. So, and of course, another purpose of the liquid in the compass ball is to give the compass ball a compass card a damping effect. You know, just not to make the compass card to wobbles. You know, just make it to be stable. So that is another function of the liquid in the compass ball. So, and there is a place around this, under this ball, that is called expansion chamber. We all know what happens to heat, liquid, when heat is being introduced. When heat is being introduced, we discover that our liquid expands. So of course, you don't want such to happen. in, yes, so that of course the water will want to escape anywhere it is. So there is an expansion chamber that expands during heat when the temperature of the temperature is increases, introduced to the compass increases. So it expands, and when the temperature comes back to normal, the compass bowl, the expansion chamber, contracts back to its normal size. So that is another composition of the compass bowl. So of course, let's not forget this. This is used for correcting soft iron. These are soft iron. Anything you see outside, like Flinders bar and quadrantal sphere, for soft iron corrections. While the ones inside, the alien error bucket contains alien error ions, add ions. The outwarship containing outwarship add ions, and the forward and aft magnetic tray containing forward and aft add ion correctors. So with this, we proceed to care of compass. Okay, how do you care for your compass? What are the checks? What are the things you need to do for your compass periodically, perhaps every week, every time? You need to check at least every watch, at least once per watch. You need to check for compass error to know, okay, what problem are we having for our magnetic compass? And of course, as I said earlier, you have to check for bubbles in it and interval, and we try to top up if necessary. Then again, we check the movement of our compass card. This is called deflection error. How do we check the deflection for deflection error? We check if our compass card is actually stable. We check by introducing a magnet near the compass card. So this will deflect the compass card, and after removing, it should go back to its original position where it came from. If it does not go back to that position, that means there is a deflection error in the compass card. So then again, we also check for structural changes around our magnetic compass. We check, okay, if there is anything, any ion, any magnetic materials, such as maybe CO2 cylinders in around our magnetic compass. We don't want this around it. So this will cause deviations. So we want to check if the space around it are free of any magnetism. And also, we want to check for I want to check the location of our compass correctors, our magnetic correctors, such as the alien error magnetic correctors, the forward and aft add ions, magnetic correctors, and the outwarship. We want to check them. So how do you know that, okay, these are in position? The location of these are inside behind your deviation card. Behind your deviation card, you have the location of all correctors, all ions. And in this, you know the sizes, the numbers, and position. So it's indicated behind your deviation card. So we will want to check this periodically and to see, okay, if these are intact. Also, we want to check for electrical installations around our magnetic compass. Electrical installations, how far do you want it? We want it more than 1.5 meters around it. So we want to see if there's any change which can cause deviation to the magnetic compass and make the magnetic compass free. And if we cite any problem, or what do? We inform the master, who, of course, is the one to fix the problem of the magnetic compass. So these are keys of magnetic compass. Of course, we check the wood as well. If the wood are intact as well. Sorry. If the wood used to cover the magnetic compass are intact, then we check for illumination. That is the lighting of the compass. Okay, if they are also intact. So of course, we want to check so many things. We want to check for salt, that is, the cause of salt, our wind around our magnetic compass. So that is all the keys for the magnetic compass. And this magnetic compass also have some errors. And these errors, I would not like to go to advance, because there are a lot of errors there. There are basic errors that we can check, and the advanced error that the master is the one to check. Those ones that contains the coefficients A, B, C, D, E, and J. But I will leave that. I will go to our simple errors. Our normal error, basic errors that we check. First off, we check for retentive error. How do we check for retentive error? We check by, first off, what causes retentive error? What is the cause of retentive error? When a vessel remains in an heading, steady heading, for a long period of time, or when the vessel has been laid up for a long period of time, this causes retentive error due to the vibration of the ship and the Earth's magnetism induced in the soft ion correctors around the magnetic compass. So how do we check that? We can check that by slewing our quadrantal sphere or our Flinders bar. So while doing this, if we see the compass card wobbling, then we know that, okay, there is a retentive error. So how do we correct this retentive error? We correct it by removing it, rolling, the quadrantal sphere, the Kevin's ball, and the Flinders bar, rolling them on our deck, rolling it. This can be removed. Also, we can also remove it by a nail. A nail is eating it and cooling it slowly, So that is a way we can remove, retentive error from our magnetic compass. Also, another error we can find.
Hello,
is,
sorry.
Another error we can find there is.
Hello.
Sorry, is anyone trying to ask a question? Okay.
Echo Whiskey, you want to ask a question? Okay, you can continue, sir. I think they may ask a question in the end of the class. Or if you want to ask a question, you can please type it on the chat, or at the end of the class, you can ask.
So, another error that we found is Gaussian error. Gaussian error it looks the same with retentive error. That's okay when a vessel is being laid for a very long period of time, or has steered a steady bearing, steady course for a long period of time. But this one is a bit different. This one is when a vessel alter course, perhaps to port or starboard, after a very after steering a course for a very long period of time. So this, you don't need to correct this. What you just need is to just relax a bit. You can see, get the deviation, because you said, okay, when do we check our compass error? We check it after one of the time we check is after major alteration of course. So we want to relax because after studying a course for a very long period of time, we want to relax a bit after altering our course, because this Gaussian error is being introduced, is being induced into our soft ions. And after relaxing for a short period of time, we discovered that this goes away. So that is another error that we don't need to correct. It's correct itself. So of course, I've told you about deflection errors as well. So I think you know that by deflecting the card with a magnet. So so what are the useful what do we mean by, what is the function of a soft ion magnetism? Let's say the Flinders bar and the quadratic sphere. Okay, we said, okay, the function is to correct soft ion magnetism. So what's soft ion magnetism? You know, there are some alphabets. I wouldn't want to mention them because they are kind of advanced, but I will just brief on them. You know, for example, now there is what we call a rod C, which is an error caused by our funnel. You know, that is a soft ion magnetism behind our compass, magnetic compass. So that is a function of, that is why we introduce the Flinders bar, which is to correct that actually. So the Flinders bar corrects that, also corrects P, I don't know, but that's capital letter P, which is add ion, forward and aft add ion magnetism. So I wouldn't want to go deep into that because that is quite, if I say I should explain all this, of course, till the time we go. So of course, we have the quadratic sphere too. We said, okay, what does it correct? This actually corrects forward and aft and outwardship. So what forward and aft and outwardship do we have? So for our quadratic sphere, we have a coefficient, we have small a, small letter A and E. What is small letter A? Small letter A is a forward and aft soft ion magnetism below our compass. Let me repeat that. The forward and aft soft ion magnetism below our magnetic compass. For example, the pipe lines and our deck itself. So this introduces an error, A, small a, and the E is caused by outwardship soft ion magnetism below our compass. Of course, deck, the main deck, that is what we call E. So we use our quadratic sphere to correct these errors. As I said the art earlier, the art is run by a field, magnetic field, as we saw in the first diagram, is covered by a magnetic field. Of course, the magnetic field, the add ion magnetism are introduced to the ship when the ship is being built when the ship is being built is when we have this hard iron magnetism introduced, maybe at the northern hemisphere or at the southern hemisphere. That will tell us where our hard iron called capital letter E, P, Q, and R. Capital letter P is our fore and aft hard iron magnetism, which affects the ship bow to stern of the ship. While the Q is athwartship hard iron magnetism. This affects the side of the ship, the hull, the starboard side to the port side, while the vertical iron magnetism affects the ship from the deck to the keel. These are hard irons. These are hard iron magnetism, which are being corrected by the hard irons magnetic correctors, which I've mentioned earlier. These are the Ealing error bucket, the forward and aft hard irons, and the athwartship hard irons. So that aside, then of course we have the soft iron magnetism too. The soft iron, which I've been explaining, the small letter A and small letter E. But let me just complete it for you. We have a small letter C as well. I think I said that one earlier too. That's a vertical soft iron, which is magnetism, which is behind our magnetic compass. Then we have a small letter F as well, which is vertical iron, soft iron magnetism behind the compass. Beside the compass. For example, now our antennas at the Monkey Island, we can sight them beside our compass. This also affects the magnetic compass. Also, we have a vertical soft iron magnetism below the compass as well. Another one, which is the accommodation. This is called small letter K. That one is the effect of our accommodation underneath our magnetic compass. So this introduces soft iron. Of course, what soft irons, of course, we use the Flinders bar and quadrilateral sphere to correct the soft irons, while we use all those others to correct hard iron. And there is this Ealing error that is being introduced on the ship while the ship is sailing, perhaps when the ship is rolling, this I will just try my best possible to explain this so that you will understand, because this requires some diagrams for us to be able to understand very well. This Ealing error introduced to the ship, as I said earlier, when the ship heels. So it's like when the upper side heels to the lower side, we can see that, okay, there is a magnetism introduced to the compass card, the magnetic compass. So how do we remove this Ealing error magnetism? We remove them through using of our Ealing error bucket. This is quite difficult to remove. These errors are caused by, of course, our coefficient is called coefficient J, which is caused by vertical hard iron magnetism. That is, of course, we know that is capital letter R. Then the small k, which is vertical soft iron magnetism below the compass. Example I made earlier, our accommodation. And the third one, the E, small letter E, athwartship soft iron magnetism below our compass, which is our deck. The combination of these three causes Ealing error. So that is where we have our Ealing error bucket inside our barnacle. This is our magnetic compass. So how do we correct this? of course, I will leave that for the master, because this is by, of course, moving of ship. The compass character does that, and the captain of the ship can also do that. So these are the few errors that I will want to discuss with us at this level. And of course, advanced level, we have what we call split B. We have we have other things, but of course, I wouldn't want to go into that. So by rounding up, I will just, of course, we're not going too deep this because we are not preparing for SQ, we're just preparing for orals. But we know the difference between our magnetic compass and our true compass. Then, of course, this deviation, what does it call? Is the difference between, angular difference between our compass heading, our magnetic, from our compass heading and our magnetic heading. That is the difference between this, the difference between these two is called the deviation. I know we are familiar with this CDMVT, because captain's doctor make, so we know that CDMVT, which is a compass deviation, magnetic variation, and our true heading. So state compass heading, difference between compass heading and magnetic heading is called our deviation, while difference between magnetic heading and true heading is our variation. So we know where to get our deviation from our deviation card, and we know where to get our variation, which is on our chart. So the combination of this is called the compass error, So I think our time is fast spent, and I think this is basic things we need to know about the magnetic compass, the care of magnetic compass, the function, the error, the correctable errors, and of course, the composition of our magnetic compass. So I would like to ask some questions and see if we have been following each other since we started. So I want anyone to tell me how many types of card do we have in a magnetic compass? A magnetic compass card, how many compass card type do we have? Are we there, please? Okay, okay. You can go on, sir.
I think you mentioned two. You said the wet and the dry.
Yeah, that's very correct. We have the wet and the dry. The wet, I said, is made of the what do you call it? The mica or plastic. Why the dry is made up of rice paper. So another question is when we find a bubble inside the compass ball, how do we remove it?
Hello, good evening. My name is Chika Dibia.
Yeah.
You said we introduce a ethyl alcohol to remove the bubbles from the compass.
Yeah, that's very correct. You introduce ethyl alcohol to remove the bubbles. Yeah. So Chika, if I may ask you, what is the effect of the liquid in the compass ball?
Hello,
Hello, is that Evan?
yes, sir. It's Alvin here. Good evening. I just want to know how you remove the bubble. You just saying you remove the bubble. Is there a specific way? Must you open something in the compass, or how should you remove it?
Yeah, that's correct. I said it earlier. There is a place behind the compass, beside the compass ball. There's an opening there where you introduce your needle. You put ethyl alcohol inside the needle, that you introduce it in it. I don't have the diagram here, but if you have if you are on board, or of course you find yourself having a magnetic compass around you, the ball, you can check. You see an opening beside it, you remove, then you introduce the ethyl alcohol there.
Okay,
So, yeah,
in the needle in the alcohol will be specified in the manufacturer's paper as well, I guess.
come back, please.
Well, this type of alcohol in the needle that we are using to remove the bubble, will it also come with the compass, or will it be in the case of the compass?
Yes, of course. You have at the back of your bridge wheelhouse, you have your compass room where you store your maybe perhaps spare compass ball. So you have
Yes,
all,
yes.
yes, you have the gadgets there. So if you can check very well, you have the gadget here, and you have ethyl alcohol. So you just introduce ethyl alcohol into the needle. You understand? Then you introduce it into the compass ball.
Okay,
So
okay, thank you.
It's a very simple process. You can perhaps, I think there's a video on YouTube. So you can go on YouTube, search for this. You'll see it, the way they are introducing this.
Okay, okay, I will do that. Thank you.
Yeah, you're welcome. Chika.
Captain, back to your question.
Yeah. So I said, did you hear me well?
Yeah, I heard you. You asked what the water in the bowl does.
Yeah, that's correct.
I think the water helps prevent the alcohol from evaporating.
Okay. Okay, what again?
I think that's the only function I know now.
Okay.
So we're using the alcohol especially for the colder polar regions to preventing from freezing.
Yeah, that's good. So liquid inside it is for, especially the alcohol, is for anti-freezing. You know, so anti-freezing, I said it to a temperature of minus 35 degrees. You discover that your liquid, so far you put the ratio, the required ratio in the compass ball. You understand? Sorry. So you have the ethyl alcohol 2:1, ethyl alcohol to distilled water 2:1. So if you put the actual ratio, then you are in good shape. So when like Chika said, when you find this thing, this bubbling, you introduce only ethyl alcohol. Okay, so another function of the liquid that I said earlier is introduce damping effect for the card not to wobbles. So it helps to damp the compass card in it, so it's stable. So that is another function of, and also to make it float as well, to make the card float and dampens the card. So another question I would like to ask is, what is the function of an expansion chamber in the compass ball? Can anyone tell us the function of our expansion chamber? Yeah, okay. So as I said earlier, the function of expansion chamber is to help during when more heat is introduced in the compass. You understand? For example, now maybe the ship always sails at a cold region and come towards the equator, that is the hot region, at the warm area, temperature changes. We all know the people that goes works with, of course, it happens everywhere. If you're carrying your oil, your fuel, you discover that during the change of temperature, the liquid expands. So when this liquid expands, the chamber, there's a chamber, expansion chamber, that expands as well to compensate for the expansion of the liquid inside the compass ball. So this is the function of the expansion chamber. It will help because, of course, when the water increases in volume, you don't want the effect to have, you don't want it affecting your compass ball, maybe breaking something or the glass trying to break. So the expansion chamber, when expanding, we compensate for that. So another question I will ask, I want one person to tell me 3 ways to care for our magnetic compass. We have many. So I want someone to just tell me 3 ways to care for our magnetic compass.
Yes, it's Alvin here. So how you
Yeah.
care for your magnetic compass is to calculate your compass error, also to make sure that your electronic equipment or items made of steel are kept away from the compass position.
Good.
And the hood, the cover should be on when it's not used. So you must cover it.
Sorry, come back with the last.
Keep the hood cover.
Yeah,
You should
good.
protect the magnetic compass.
Yeah, that's correct. So that is 3. Can anyone tell me another 3? Can anyone tell me another 3? Care of our magnetic compass. This is what we need to do all the time. So that is why we need to know this, you know, so that because, for example, now when the ship is laid up for a very long period of time, you are a captain, you go on board. What do? The first 2 things you want to do is getting your SMS manual and checking your magnetic compass. Those are the things you want to do as a captain. So that means this magnetic compass is very crucial on board the ship. It's something that we need to care about. So if anyone can tell me another 3, or should I go ahead? Evans has told us about compass error. He told us about keeping the wood, and also electrical appliances around it should be away for more than 1.5 meters. So the rest, yeah, I can tell you. Okay.
I saw in some of electrical equipment, they actually say safe distance should be 4.5 meters. They actually say it from the magnetic compass.
Yes, you can. That is fine, 4.5 meters, but anything more than 1.5 meters, perhaps 2 meters, is also okay. You understand? So you want to keep eye on it and see, perhaps maybe your electrician comes to the wheelhouse and fix something. You go to the Monkey Island and fix something. You want to make sure that the equipments are stayed away from your magnetic compass for more than 1.5 meters. So, okay, if I may complete it, let me just repeat others. Of course, you want to check for bubbles all the time. You want to check for bubbles. You want to check for structural changes around it, such as maybe your filter work around it, did hot work around it, that now left the cylinder, CO2 cylinder or acetylene. So you want to keep that away from your compass, your magnetic compass. Also, you want to check for the location of your correctors, your magnetic correctors, such as the add ions magnetic correctors, the ones in the Allen error bucket, the ones, the forward and aft corrector, and the outward correctors. This, I said earlier, can be found behind our deviation card, the position, the size, and the location. Also, you want to check for what do you call it? Okay, I've said bubbles, movement of card. Of deflection error, I want to check for, want to introduce a magnet and see if it wobbles, you know. So if it goes away and after removing it, it should come back to its original position. If it doesn't come back to the original position, that means there's an error. There's a deflection error you need to fix. So I would like to stop here today, and I hope I've been able to transfer the little knowledge I have to our fellow seafarers. And thank you very much. Yeah, over to Captain Bisayo.
Thank you so much. Bless you.
Yeah, thank you,
Thanks,
sir.
boss. That was
Thank you. Thank you so much for the lecture.
Yeah, thank you, sir.
thank you very much. I had so many notes here from this great knowledge.
Just a quick one, Captain Busayo. Hello, Captain. Sorry, just a quick one. This Tayo here. I just wanted to pick on Kevin's comment about if there is a notice that says you should keep an equipment 4.5 meters away from the compass. So it's two things. If there's a manufacturer's instruction that you should do that, please follow what the manufacturer says on that particular equipment, because it's for the safety of that equipment, all right? Not really for the compass. It will affect the compass, yes, but also you don't want your equipment to get damaged. So you should please comply with that. If they say keep it 10 meters, keep it 10 meters. But standard equipment, basically, we try to keep it a meter 0.5. So also your wristwatches, if you have a very good wristwatch, try to don't take it close to your compass. You could damage your wristwatch, and your wristwatch will also could have effect when you're going to take your gyro compass errors, or if you want to work on your compass. So keep your wristwatches away. Thank you so much, Captain Johnson, for this. It's not small, you know. Thank you so much. It reminds me of all the coefficients, E and all that. You could actually do a, what's it called? You could actually do a PhD on coefficients. So it's a big subject. Yeah, it's a big subject. Thanks so much. Captain Busayo, over to you, sir.
Yeah, Captain Johnson, I don't know if you have time to take questions, just one or two.
Okay.
Okay, if you have any question, please let me know, starting from Chika. I think Chika has a question. So Chika, unmute yourself and let's go.
Okay. Good evening, everyone. Chika Divya.
Yeah, good evening.
Okay, I always have this problem with the difference between the compass course, the magnetic course, and the true course when on board. Because whenever we're on board, we always deal with the compass course. Tell you your compass is, you're doing this compass. And I'm also meant to understand that the gyro compass gives us the true course of our vessel. So I'm always confused when I'm doing compass correction, and I have to be looking for the compass course, while already I'm taking my compass course from my gyro compass, which is giving me true. then I still have to look for the compass course and also the true course again. So I really want a
Okay, I understand you, Chika. There is
clear
like
someone to help me clear.
okay, all right, Chika. Like I said earlier, there is something, I don't know if you wrote it down, CDMVT. It's from compass to magnetic, from magnetic to true. Of course, our magnetic compass should give us magnetic compass if there is no deviation. But if there is deviation, our magnetic compass is actually giving us compass course, compass heading. You understand? So you have to add or subtract, depends on your heading. You have to add or subtract your magnetic, your deviation. You know, there is an acronym said CADET, we said from compass to true, add east. Then vice versa, you add west. That is CADET, cadet. Compass, add east to true. So that is the way you get your magnetic compass. So your magnetic heading. But from magnetic heading to true heading, you get it with V. That is the variation. The variation I shared with you that you will get, hold on one second. You get from this compass rows. Okay, can we cite, can we see this? Yeah. So this is our compass rows that we find on our chart. This is our variation. So with this variation, you can get your true heading. So from your compass to magnetic, you apply the deviation. Then from your magnetic to true, what do? You apply variation. Of course, gyro will always give you true heading. Yeah. So you say, okay, why do we need gyro? Gyro, the difference between gyro and a magnetic is because gyro use power, magnetic does not use power. If you correct your magnetic very well, you always use magnetic even when there is no power on your ship. But the advantage of gyro to magnetic is because it's being input into other equipment on board the ship, such as the EGDIS, the cost recorder, the AIS, the, you have the autopilot, you have, without you, that is why we are using gyro. But with magnetic, if I can answer your question very well, from magnetic to true, and for compass to true, you have to apply your deviation and variation. When you apply your variation and deviation, it will give you true heading. Confirm you read me.
Okay, sir.
Okay, let's stop showing this.
All right, thank you very much. Does anybody have any further question?
Yes, sir. Good evening.
Good evening.
Okay. Good evening, sir. My name is Lois.
Okay.
In line with the question Chika Dibia asked, sir, you illustrated with CDMVT.
Yeah.
Now you made mention that the magnetic compass gives us the M, which is the M in the acronym.
Yeah.
Now, when we get the magnetic compass reading, do we write it as the C, then applying deviation, or we write it as the M? I need to be clarified with that.
So what I said earlier was that your magnetic compass give you compass course. compass heading if there is no deviation.
Okay.
You understand? So if there is no deviation, how do you know? You have your deviation card at the wheelhouse, right? We state, okay, if you are going through this heading, this is what your deviation. This has been constructed by your compass adjuster, or perhaps maybe your captain did it during tentative swing, full swing after tentative swing. That is for emergency. You can do emergency deviation card. So your heading, not your ship heading, not your bearing. It's your ship heading that you check this deviation from your deviation card. You understand? So from there, you will know if there is deviation on your magnetic compass. Of course, you check your compass error all the time and you calculate this out on your own. That should be done at least once per watch. You understand? So when you check your heading, you know that, okay, you go to your compass card, then you know the deviation. So from the deviation, you know if it's east or west. I said from compass to true. That is from compass to magnetic, you add east. From then you subtract west, where you're converting from compass heading to magnetic heading. You understand? So that is converting compass heading to magnetic heading. So any other question?
Yeah, I have a question.
Yeah.
The name is Alex Young.
Oh yeah.
So the challenge is having to fill this compass deviation book.
That is another destiny, because you have to do your compass error. You have to use the azimuth mirror to take the sun and do your calculation. That requires a calculation using your Norwich table or almanac. Perhaps some other time we can do that.
Okay, no problem.
We can't do that now. It's quite a long process.
Okay, no problem. Thank you very much.
Yeah, thanks, boss. I think for that question, it's something most of our OWs are finding difficult on how to fill the compass deviation. But I think we can take it as a subject. One day we just get a compass collection and form, and then we just start going through bit by bit, so everyone can be united. Because on my ship, if I want to punish my second officer, I tell them to go and do compass collection. But yeah, thanks, boss. I really appreciate this, and thanks for your time. I would like everyone to say congratulations again to Master Mariner, Captain Olubunmi Johnson. It's really a very nice privilege.
Congratulations, Captain Olubunmi Johnson.
Yeah, thank you very much.
All right, then. With that, if you have any other further questions, you can drop it on the chat, and we'll be glad to handle it. So thanks, everyone. Captain Anson, Captain Tayo, Captain Joshua. I saw Captain Solomon the other time, and everyone. Thanks, everyone. And have a lovely week. I hope boss will be able to bring you back again to come and continue feeding us.
Yeah, okay, I'll try my best possible, sir.
No problem. All right then. Thanks, boss. Bye, everyone.
Yeah.